In front of me, I have the AP Chemistry free response questions from the year 2000. Today, we will be solving question 6, parts D and E. In part D, they give you an information table, and you must write the rate law expression for the reaction and explain how you obtained your answer. In front of me, I have copied the information table from the question and color-coded it in order to differentiate between the different experiments. Experiment 1 is depicted in red, Experiment 2 depicted in light blue, Experiment 3 depicted in pink, Experiment 4 depicted in purple. By simply looking at the question and the numbers given, you can determine the rate law. However, if you're not comfortable with doing it that way, there's also a mathematical way. This is the mathematical way. By comparing experiments 2 and experiments 1, we can figure out the rate of reaction for Y. We picked experiments 1 and 2 because X was held constant, X being the initial amount of O3. In step 1, we set up the equation, the simple rate law equation, and input the numbers. In step 2, we remove our constants. K will always be a constant, and O3 was held constant in both experiments 1 and 2, which is why we decided to compare them against each other. In step 3, we solved. 0.0020 divided by 0.0010 gives you 2 to the y, because you bring down the exponent. And then you make it equal to the initial rate of formation, which you will obtain from your data table. So your final step, which would be step 4, you get 2 to the y equals 2 by solving y equals 1. As we have determined, y is equal to 1. So now, in order to solve for x, we will compare experiments 3 and 1. K will always be held at constant, and y was a constant number because we chose experiments 3 and 1, and as shown in our data table, the initial amount of NO is held constant at 0.0010. In step 3, we solve, and our final equation is 2 to the x equals 2. X is equal to 1, making our rate law K O3 to the first and O to the first. What we know now from the mathematical way is K will always be held constant, so that number will not change in the rate law. We solved x is equal to 1, and we solved y is equal to 1. So now we plug in our values to our rate law, and thus the rate equals K, concentration of O3 to the first, concentration of NO to the first. And that is the answer to part D. In part E of the question, we are given a 3-step mechanism. We must identify the step that must be the slowest in order for this mechanism to be consistent with the rate law expression that we derived from part D. Our rate law expression, in case anyone forgot, is K is equal to the concentration of O3 to the first, concentration NO to the first. By simply looking at steps 1, 2, and 3, we can determine step 1 is the rate determining step. The reasoning as to why step 1 is the rate determining step is because step 1 is the only step that follows the rate law determined in part D. Why steps 2 and 3 are wrong. Step 2, the rate law would be second order with respect to O3. Step 3, the rate law would be second order with respect to NO. And because those are the rate laws, they don't follow the data that is given to us in the initial problem. I hope that explained question number 6 from the AP Chemistry Free Response 2000 section, parts D and E. Good luck with future endeavors.